Recently, Intelligent Plant helped facilitate the OGTC Codeless Hackathon event. That's an oil and gas technology centre whose mission statement it is to unlock the full potential of the UK North Sea through innovation and transformation. It was really something else. Over 100 people from all over the world signed up for a 4-day hackathon challenge. The objective was to demonstrate how anyone can become an industrial data scientist if given the right tools. Microsoft provided tutorials and mentoring for the Power Platform. Organizations such as Ithaca Energy and Catapult set challenges that were based on genuine issues they face in their industrial processes. And Intelligent Plant provided the connectivity that allowed participants to explore and analyze industrial data. And by that, I don't mean they were given a spreadsheet with some numbers on it. No, participants used the industrial data connector from Intelligent Plant that ships with Microsoft Power BI. Let me give you an example. Ithaca Energy challenged participants to build a greenhouse gas smart meter for one of their North Sea oil and gas platforms. That's a real requirement. All industry has an ethical and legal requirement to understand and reduce their carbon footprint. A senior process engineer explained how oil rigs work, the machinery required to extract oil and gas from deep underground, and the power consumed. And because Ithaca Energy used Intelligent Plant software, he was then able to authorize all participants of the hackathon to access their process data historian. That's their primary data repository where all data from the oil rig is stored. A textbook example of collaboration. Now, at Intelligent Plant, working with vast industrial data sources is our bread and butter. We know how to connect to them, we know how to interrogate them, and we've developed tools that allow others to do the same, such as the Industrial Data Connect for Power BI. But we may occasionally underestimate how empowering this is and how radically different it is to what most people are used to. What we saw during the hackathon were some teams attempting to download all the data. Yeah, get all the data, then we'll filter through it and find what's interesting. For people used to working with the constraints of a finite data set, a spreadsheet, that is a perfectly reasonable thing to do. What they hadn't grasped was that they really did have a live data connection to a genuine process data historian. Process data historians are the original big database. To understand how to query them, it helps to know a little about how they work.
To understand the optimal way to query a historian, it's important to understand a little bit about how they work under the hood, and how they differ to the relational data sources and CSV files that are commonly used in many tools.
First, let's talk about the type of data that a historian is designed for, time series data. Time series data describes changes in value, usually from some sort of instrument, over time. It can also include additional metadata, such as information about the source of the data, or a status indicator that can tell us if there are any concerns about the quality of a reading, such as calibration issues with the underlying instrument. In an industrial process, it's important to record both what the current state of the process is and what it looked like in the past, so that the process can be continuously monitored and optimized for both safety and performance. This is the role of the historian. So what is a historian? It's a data store that is optimized for storing and querying time series data. In an industrial process, such as a wind farm, a factory, a paper mill, an oil rig, and so on, there are typically tens of thousands of instruments that are continuously emitting data, such as temperatures, pressures, rotation speeds, valve positions, flow meters, and so on. These instruments emit new values every few seconds, or even multiple times per second in some cases. A historian must be able to continuously ingest this incoming data, filter out values that it is not considered to be meaningful, permanently record the values that are meaningful to its archive, and simultaneously respond to queries from people and applications trying to analyze the process in real time. In order to be able to do all of these jobs simultaneously, the historian needs to be smart about how it processes and stores time series data. As we've heard, a historian receives a lot of instrument values, but not all of these values represent meaningful changes. For example, if you keep reading a temperature sensor and the value is not changing, or it has only changed by a fraction of a degree, it might not be worth the overhead required to permanently record all of these samples. Each recorded value has an overhead in terms of disk space and also in terms of query performance. The more values that you record for an instrument, the longer it will take to apply a query filter to that data. When a new instrument value is received, the historian will always update the current recorded value for the instrument. This current value is usually referred to as the snapshot. However, in order to reduce the number of samples that are permanently recorded to its archive, a historian will often apply filters to incoming values to determine whether or not an incoming sample represents a meaningful value change. If an incoming sample is not considered to be meaningful, it can be safely discarded, reducing the disk space required without sacrificing the integrity of the data. Let's look at a worked example. In this graph, we can see a stream of instrument values coming into a historian, 25 in total. As you can see, there are quite a few samples where the value is not changing at all, or is only changing very slightly. We can use the first stage of the data filter, known as the exception filter, to remove these samples from the stream, since they do not represent meaningful value changes. As you can see, by applying a simple filter, we've already removed about 1/3 of the original samples, marked with an orange cross, but we can cut this down even further. The remaining samples, marked in green, are then passed on to the second stage of the data filter, known as the compression filter. The compression filter uses angles to detect if incoming values represent meaningful value changes. This means that some incoming samples that form a straight line can be safely removed without affecting the overall shape of the incoming dataset. After applying the compression filter, we've managed to remove another 1/4 of the original dataset, but the final dataset still has the same shape. In a production system, we would only expect 10 to 20% of all incoming values to make it through both stages of the data filter and into the permanent archive. This is a lot to take in, but this knowledge really helps with our understanding of how best to query the historian. Based on what we've learned, we can see why downloading all of the data is not a great approach. The historian is a live system monitoring a live process, and it needs to be available to provide data related to safety and business critical functions. In order to fulfill these obligations, most historians will apply restrictions on the number of samples it will allow you to request in a given query. We also saw how the historian filters out samples as they come into the system. This behavior, combined with the fact that different instruments may be polled at different intervals, means that the data does not always line up nicely in a tabulated format, the way it would in a CSV file, for example. This can make things tricky when working with tools that are optimized for working with tabulated data. Fortunately, most historians support performant ad hoc aggregation of data, enabling you to retrieve data in a tabulated format better suited to use in many tools. Examples of aggregated data queries include: what is the average value for each hour in the previous 24 hours? What was the percentage of good quality data recorded on each day in the last months? Or calculate the interpolated value of the instrument 5-minute intervals over the previous hour. These queries do not overburden the historian, but still give us the data we need to do our analysis in a tabulated format. It is also important to think about where the source data comes from. If our instruments are only being polled every 10 or 15 seconds, there's no point in requesting aggregated data at a 5-second sample interval, as this will just result in unnecessary results being computed. You can always use a tool such as Intelligent Plant's Gestalt Trend to examine the raw data for an instrument and infer what the lowest sample interval for your query should be. Armed with this knowledge, I hope you now have a better understanding of how historians work, why they operate in that way, and how to plan the queries you need to use in your data analysis.
We should point out that there are safeties in our connection software that prevent queries from potentially overloading a process data historian. Instead, all we had at the hackathon were a bunch of participants scratching their head wondering why their queries hadn't worked, until we gave them a hand. So, what is the correct approach?
Thanks, Graham. Thanks, Gregor. Using Industrial App Store Power BI connector, I can create a sample dashboard where we don't need to have all the raw data handy, because we can dynamically requery for specific time periods that we are interested in and update the dashboard. So let's take a look. At the moment, my trend is displaying last 300 days. Industrial App Store allows us to specify time constraints using relative time periods, which I'm utilizing here. Main advantage of this is so when I publish this dashboard onto Power BI service and set up a background refresh, it will always be up to date. To accurately visualize the trend, we only require 2,000 points. Because my dashboard is less than 2,000 pixels wide, I can't show any more resolution anyway. For example, if I request 5,000 points, there isn't enough real estate to display that, so at least 3,000 points would be discarded. When I want to zoom in and examine an area of interest, I can simply edit the parameters and set the time span I'm interested in. What happened here is Industrial App Store Connector went away and requeried for the time period we have requested. The number of points is still 2,000, but I'm seeing much more detail because my time span is much shorter. I'm using the plot aggregation, which is specifically designed to show the best shape of the trend by representing all the peaks and troughs. Utilizing the parameters in Power BI, I transfer only the data that I'm interested in, thus reducing the bandwidth, load on the source system, as well as my own computer. I don't need to extract 10 years worth of raw data, which will take a long time, even if industrial historians support that. For example, a CSV file for 1 month with 570 tags at 1 second resolution is about 9 gigs. And if you want 10 years of data, well, you can do the math. Furthermore, we have alarm and event data available, which can be utilized to further investigate issues. Good starting point is to look at sequence of events. To browse sequence of events data, which can be millions of rows or events, I can further parameterize the query by adding page number and page size parameters. The report is still filtered by the dates, but having paging parameters allows us to drill down to a specific event, for example, a shutdown. Again, we're not downloading 10 years worth of data because some systems might contain a lot of noise that contribute to overall size. For example, some assets might have 1 million events for 5 days or even 5 hours recorded. So you can only imagine what 10 years would look like. Industrial App Store enables Power Platform data retrieval that can show great level of detail for a data scientist to come up with a machine learning algorithm without having tons of raw data downloaded, or a brief summary overview that engineers can use to spot an issue straight away.
To find out more about how Intelligent Plant can help your organization on its digital journey, how to connect your data sources to the best analytical tools on the market, and how to empower your teams, get in touch with us at intelligentplant.com.